Hello, beautiful people. Future me. Welcome to another. Well, what is it? Programming workout, it is. Where I'm trying to improve my programming skills. Let's get into it. Closure. Okay. Three minutes. That wasn't so bad. At least I feel 2%. That's good. That's good. 39. That's all right. Oh crap! I don't want to upgrade. I want our next lesson. A lot of mistakes. Yeah, I need to change my layout. The cording kinda, I think, strains my hand. Okay, 6, almost 7 minutes. 5%. It is what it is. Keep practicing. And I do the execute program, yes sir. I was doing TypeScript, I think, the session before. Hopefully it will be JavaScript or SQL. Cool, SQL. Sounds good. Let's do it. That was SQL. Review. Let's go. Okay, so we are creating a table users as ID, name, and discount ID. That's the primary key ID. Name is text, and discount ID is foreign key. Okay, and it has a discounts, can be null though. And we are creating the discounts that has ID and discounts code. Okay. Two users can't reference the same discount. Yeah, because the discount ID is unique. So this one is error. Code like give the rate where these comments be removed from you. So we have a people integer ID, then the cats. Cats have a foreign key owner ID and three fields: ID, owner ID, and name. Then we are inserting Amir and Mrs. Fluff. Okay. Betty and Kinu. Good. Now what? We are selecting the cat ID and cat ID and person ID, and we are joining from people join cats on people ID cats owner ID. Okay, so the first one will be so it is cat's ID. So it will be cat ID, and that will be the one. That will be one, and person ID will be Amir, which is 100, and the second one will be Betty and Kinu, so that will be cat ID will be 2, and person ID will be 200. Check for typos, cat ID, person ID, cat ID, person ID, looks good. Now we are creating users, same thing, comments. You have a comments and user ID, that is the foreign key. User ID, user's ID not null, and we have a text not null. Two comments can't reference the same user. Okay, so I can just write error in here. But why is it? We are inserting into comments, and can reference the same user. So this will be okay. Do we have the user? Amir, yeah, we do. So this will be okay. What about this? Create table users ID integer primary key name text not null. So we have users with ID and name. Name is not null. ID is primary key. Then we have a foreign key user ID in the comments table, which is also not null. And the comment text also must be not null. So comments must reference a user. Yeah, so this is error. Create table people. People, two primary keys. This is an error. Drop the cats table. Exec. Drop table. Cats. That's it. Use a join to find cats and their toys. The join should return two columns aliased with cat and toy. Okay. Select, and here we will have uh, cats dot name as get uh, toys dot name as toy from, and here will be cats join toys as on cats dot id equals get toys and cat id mouser. Cats have an ID, so get ID. Get I think this would be okay, and it is. So then table users, ID name, and the discount ID, which is foreign key, should be null and unique. And the discount. So insert into users, and that will have no discount, so this is okay. Select two values from the cats table. First, the cat's names with the cat appended to each. Second is 3 years old, a boolean. And the equality operation is the single. Okay. So we want select. Yeah. So age equals 3, s is 3 years old. Then we will have a name with appending the cat, so that will be name pipe, and here we will have the cat as name, I think. Yep, name. And now you'll say from cats. Close it. So we are selecting age equals is 3 years old. That is the first field. The second one is name, appending the cat as name, everything from cats. What's the problem? I have a typo. Yarther. I have, yeah. Here's the typo. Create table users, email not null, text not null. We are not inserting null anywhere, so this is good. And we are inserting 4 rows. Amir, two Bettys, one Cindy, and then we are selecting from users. We are selecting email, so we will have this result, and we are selecting email. So email, where the name is Amir or Cindy. So it will be Amir at example.com, the first one, but that is string. And the second one will be email, also an object. Email, and that is Cindy. Cindy at example.com, like so. Check for typos. Email Amir example.com. Email Cindy example.com. Create a table with a primary key on a name text field. Make sure the primary key is not null. Table people, and here we will have a name primary key not null, like so. A text, okay. Creation of the table, email text, name text, draw table users, and then we are trying to select it. So this is error because users do not exist anymore. So we have people and cats, tables, same old stuff. Then we have insertion of two cats and two people, well, respectively, and then we are adding third cat for Betty, named Kim. Then we are selecting person and a cat from people, join cats on people ID equals cats owner ID where people first name Betty. Okay, so that will be two results. And we will have person will be Betty, then cat will be, the first one is Kinu, and the second thing will be Betty as well. Betty, and cat is called Kim. Person Betty, cat Kinu, person Betty, cat Kim. Yeah. Second chance. This is where I did the typo. So I will select age equals 3, as is 3 years old, no typo there. Then we will have a name appended with the cat as name from cats age equals 3, as is 3 years old, name appended with the cat as name from cats. Very well, very good. Sure, I can choose randomly. This one. Null and unique constraints. What happens if there's null in a column with unique constraint? At first glance, here's what you might expect. One null is allowed, but multiple nulls will violate the unique constraint, but that would make some things very difficult in practice. Here's an example. Suppose that we have a users table with an email common, which has unique constraints. Some users will register with a third-party authentication system like Google, Twitter, or GitHub. Those users will have a null email address column. If a unique constraint only allowed null, then only one null, then only one user will be allowed to register with those third-party authentication systems. After that, all further registration attempts would violate the unique constraints. For exactly this reason, unique has a special behavior for null. Null values are effectively ignored by unique constraint. In the following examples, you can answer with error if a query will result in blah blah blah. So create user, this is okay. Now what? This okay. Whoa, what happened in here? Then we are inserting into user's email. Well, this now select. Okay, so this will be select all from, so we will have the result, and inside of it, it will say, users we have a just email, so email null, like so. We are inserting into the table two same things, so this is an error. Error. Then what? We are inserting two nulls, that is okay. Yeah, so, but we will have this. Email null and the same thing. Null. Sometimes language quirks are mistakes. Language designer might not anticipate problems with the language they designed. This null unique behavior is a quirk, but it's not language design mistake. It's an intentional choice that allows us to build databases like the one above. Okay, and we finished. Okay, cool. In a previous lesson, we used join to list all pairs of people and their cats. We could have done that by looping in JavaScript, querying to find each person's cats. In this lesson, we will see why we choose to write join instead of using JavaScript. In this lesson, our database will always be set up with a people table and cats table. The cats table has an owner ID, which is a foreign key to a person. Amir has a cat name, is a Fluss, Betty has a Kinu. You'll see this in the setup for each example, but it's always the same, so you can skip reading it. Oh, thank you. First, let's get every person and cat pair using JavaScript. Finish the function people and cats so that it creates a list of each pair of cat and person for every cat. Call results push. What? Finish function people and cat so that it creates a list of each pair of cat and person for every call. For every cat call results push. To build up a list of results. So I'll just write what they told me. Okay. So I will push the object. It will be person name and cat name. Person dot name cat will be cat dot name, like so. that's what they wanted. What we are doing here with the results, we select everything, the people, and then we are iterating over it. Unexpected end of input. Okay. This is correct in the sense that will return the right results, but it has a big problem. Its performance is terrible. What happens if we have 10,000 people? Our outer loop for const people will run 10,000 times. We'll do that a total of 2001 queries. One query to find all of the people, then a separate cat query for each of the 10,000 people. This is a very common problem when querying any kind of database, SQLs or otherwise. It's called an n+1 problem. We do one person query, then n 10,000 cat queries. That's too many queries. We can afford to put that much load on the database for a single page view on our site. We'll fix this in stages. First, let's reduce the number of queries. We'll get all of the people and then call all the cats. Then we write a nested loop. For each person, for each cat. If this person is a cat owner, okay. Add an entry to the results array for each person, cat where owner equals the person ID. So we get the queries, the cats, and then we are comparing them, right? Yeah. So 2 queries only in here. This is better. And if that will be person.id equals cat.owner ID it was, right? I think so. Then we will edit and we will do results.push, and we will push an object, and it will be what? Cat will be cat.name, and person that will be person.name. Close the object, the if is closed, for is closed, boom. We reduce the number of queries to 2. That's awesome. But we still has a performance problem. We have 10,000 people and 10,000 cats, but we only want to retrieve Amira and his cat, Mrs. Fluff. We could do it by calling our peopleCat function and filtering its results, but we end up retrieving a total of 20,000 rows from the database, even though we only need to. Also, even though we've reduced the number of queries, we made our JavaScript very slow. The inner loop, what looks at each cat, runs 10 times for every iteration of the outer loop. For every iteration of the outer loop with 10,000 people and 10,000 cats, the comparison of owner ID to person ID will run a total of million times. Well, 100,000 times. All of that just to find out that Amir owns Mr. Fluff. This method does not work in real systems. Here's relational databases show their usefulness. We can use join to get the same result. Right select from join on query to get a list of all cats and people. Remember to select people name as person and cat name. Yeah, sure. So this one, then we are inserting those things, and we will select what do we want? People dot name as person. Then we want cats dot name as cat from what from from people join cats on people.id equals cats dot owner id. Ship it. We got the same result in a single database query. This fixes the two performance problems we talked about so far. It requires only one query and it doesn't have any nested loops. What's really going on in the joins? So far we have been thinking about joins as nested loops, similar to the ones that we wrote in JavaScript above. Aren't we just asking the database to do iteration which will be slow? Fortunately, no. Nested loops are a perfect mental model for how join works, but they are only a mental model. In reality, the database will optimize the query, rebuilding it to be more efficient while still giving the same results. Here's a concrete example how to answer here. Answer here should be identical to the one above with an extra where added. Write a join, query to find all the cats, download person with name of Amir. Okay, so I'll copy this, paste it in here, maybe. Copy, pasty. What? Cannot copy it. Okay. Select person dot name as person. Then we will have cat dot name as cat from people join cats on people.id equals cats dot owner id. And that was the previous here where people dot name equals Amir. In the example above, where people.name equals tests the database that tells the database that only one person matters. Then on people.id, cats owner ID tells it that it only needs to consider cats owned by that person. By understanding both of those limitations, the database can execute the query more intelligently. It will do something similar to select star from cats where owner ID. So they will select only the cats that are relevant. This is impressive. I still It's still a simple example. The bigger the query gets, the harder it is for a human to optimize manually. but the database has no such limitation. It will happily optimize and query that we come up with. Imagine that we were joining across 8 different tables instead of just 2. That's not extremely common, but it does happen. Each table has 10,000 records with 8 nested loops, so we would require a huge amount of iterations. That will take something like many years. That's more than the universe exists, right? If your database is set up properly, an 8-table join with where that matches only one row would execute in less than a millisecond. That lets us have our cake while eating it. We get to think about joins using a simple conceptual model. Nested loops with an if inside, but the query actually executes in much more intelligent way. Full disclosure, database optimizers aren't perfect. In real database, we give them certain kinds of manual hints that we'll learn about in later lessons. In rare cases, the optimizer does a bad job and we have to change our queries significantly to work around it. But in 99.9% of cases, the optimizer will do what you want. And we are done. And we are 11 minutes over our limit. We killed SQL. It's good to know. We cannot progress anymore. So SQL is done for some time. What about TypeScript? TypeScript, I have one exercise to do, one lesson, and the JavaScript has one as well. So there will be a review and lesson, I think. Okay, 12 minutes over the time. That means we are done. Done is better than perfect, and I will see you next time.